Today's video is finding the area of triangles. Now, finding the area of triangles can be tricky because it's a different formula than the formula you would use for finding the area of a square or a rectangle or a parallelogram. Students must start to become aware that writing out the formula is a great strategy to make sure that you use the numbers appropriately to find the correct value of the area. In this example, you can see that this is obviously a square, not a triangle, but you all know that to find the area of this square, you would do length times width, or 10 times 10, and get 100 centimeters squared. What I'd like to point out is this could be like, imagine this is a sandwich, a square sandwich, and you ask your parents to cut it in half. So you take a sandwich just like that, and you cut it in half right down the middle. I think everybody knows that the two halves equal one whole. But the difference is when you have the two halves, you have a new dimension now. This would now be 5 centimeters by 10 centimeters. But if I was to instead cut it in half on a diagonal, which many of you guys have done before, and cut that sandwich right across the middle on the diagonal, you would probably also recognize that the two halves would make one whole. But the difference is now the dimensions didn't change. This is still 10 by 10. But we obviously know that the area of this triangle would be half the area of the square. And so we've got to recognize that there's a key to this formula, is that the area of the triangle uses the same dimensions as you would for a parallelogram or a square, but it cuts that value in half. The formula for finding the area of a triangle is 1/2 times the base times the height. Now, the great thing about this formula is because of our knowledge of the commutative and associative properties, you can group these numbers accordingly to make it easiest for you. But I'd also like to point out that to find the area of a parallelogram, you would do base times height. But because a triangle is half of a parallelogram, that's what we've got to multiply that by 1/2. Because we need the value to be half that of what it would be if it was the whole parallelogram. Because you'll note that the base of this parallelogram is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 centimeters. And the height of this parallelogram is 1, 2, 3, 4, 5, 6 centimeters. But those are also the base and the height of the triangle. So we can't just multiply base times height to get the area of the triangle because it doesn't truly represent what the triangle's value is. So the formula for finding the area of a triangle is 1/2 base times height. Let's try that out a couple times. In this example, we'll apply the formula 1/2 base times height. I've put our height in green. I know it's a little hard to read there. This is 5 centimeters, and our base is 5 centimeters. So we're going to do 1/2 times 5 times 5. Now, as I just said with the associative property, it's probably easier to multiply these whole numbers first, or the commutative property, and group these together, and then multiply by 1/2. So we know that 5 times 5 is 25, and half of 25 equals 12.5 centimeters squared. Now, in this triangle, much like some of our rectangles or our parallelograms, the height is on the inside, and that's okay too. Remember, the height and the base always have to meet at a right angle. So we have 8 is our base and 4 is our height. So the same formula, 1/2 times base times height, will be 1/2 times 8 times 4. Now in this case, you may want to just go left to right like you normally would using the order of operations, because we all know half of 8 is 4, and then 4 times 4 is 16. And 16 centimeters squared is the area. I would like to point out if instead you chose to do 8 times 4 is 32 and did half of 32, you'd still get the answer of 16 centimeters squared. A few more examples. This is another key example because you'll note that in this case the height is not in the triangle at all. We're measuring the distance from the tallest bit of the triangle to the shortest bit of the triangle. And you'll see that that's 8 centimeters high. So even though that there's no right angle in this triangle, that is the height from the top to the bottom. Again, we're going to use the formula 1/2 base times height. You'll notice there's no need for a multiplication symbol. You got the coefficient 1/2, and then you've got variables next to each other, which we know means to multiply. And we're going to substitute, but when we substitute, we will need to replace some multiplication signs. And 15 times 8. This is a perfect example to use the commutative property and switch the order of the 15 and the 8, because I'd much rather do 1/2 times 8 than 1/2 times 15. So if I change that to 1/2 times 8 times 15, 1/2 times 8 is 4, 4 times 15 is 60, 60 centimeters squared would be the area of that triangle. A reminder, as you're doing the area of triangles, it's always a good idea to write in the, the correct formula to make sure that you're following the protocol. So in this case, 1/2 times base times height. I know that that's 1/2 times 4 times 11, but when I solve it, I'm going to go left to right. 1/2 of 4 is 2, and then 2 times 11 is 22. So you have 22 feet squared, and in this one, your base is 22, your height is 10, so we have 1/2 times base times height, 1/2 times 22 times 11 times 10, and we know 1/2 of 22 is 11. 11 times 10 is 110 meters squared. All right, that's how you find the area of a triangle. Good luck. Thanks for sticking around till the end.